Today we're going to be looking at special parallelograms. So theorem 6.9 states that each diagonal of a rhombus bisects two angles of the rhombus. So if I take a look at first just this diagonal right here, it's cutting and bisecting these two angles of my parallelogram. And since it's bisecting, it means that these two angles are going to be congruent to each other. And since we're dealing with a parallelogram, this angle is opposite this angle, which means they're congruent. So that means these two angles are also congruent. If I look at my other diagonal, it's bisecting these two opposite angles. So that means these two smaller angles are congruent as well as these two, and they're going to be congruent to each other because they are opposite angles. Theorem 6.10 states that the diagonals of a rhombus are perpendicular. And remember, perpendicular means 90 degrees. So when you have two diagonals in a rhombus, they create 90 degrees. So all four angles in this center where my diagonals intersect are 90 degrees. So let's use that information to look at example 1. So for example 1, we find the numbered angles. So we want to find angle 1, 2, 3, and 4. So we are dealing with a rhombus because we have 4 congruent sides. So that does mean it's also a parallelogram. So if this angle is 130 degrees, I also know this angle is 130, but I don't need to find that because that's not what I'm looking for. But since right here is my diagonal of my rhombus, that means my diagonal is bisecting two angles. So that means angle 1 is going to be equal to angle 2. Angle 3 and angle 4 are equal, and they're also equal to angles 1 and 2 because these are opposite angles, and opposite angles have to be congruent to each other. So if I'm looking, this right here is an isosceles triangle, which means I have two congruent sides. So that means my angles, base angles, are also congruent, which we've already marked. So if angle 1 and angle 4 are equal, and I don't know what they are, I'm going to use x to represent what they are. If I'm dealing with a triangle, 3 angles in a triangle add up to be 180. So angle 3 plus angle 4 plus my 130 is going to equal 180 degrees. So if I subtract 130 to both sides, x plus x is 2x. Means I'm left with 2x equals 50. Divide by 2. Then x equals 25. So that means the measure of angle 1 equals 25 degrees. The measure of angle 2 also equals 25 degrees. The measure of angle 3 is 25 degrees. And the measure of angle 4 is also 25 degrees. So all four angles are congruent to each other. Example 2 says, using properties of a rhombi, says the measure of angle 1 is 4x. So this angle right here is 4x. The measure of angle 2 right in here is 5y minus 20. And the measure of angle 3 is 2z plus 42. So I know what all three of those stand for, what they equal. I want to find the value of x, y, and z. Well, looking at theorem 6.10, it says the diagonals of a rhombus are perpendicular, meaning they create a 90-degree angle. So not only is the measure of angle 1 4x, it is also 90 degrees. So that means 4x has to equal 90 degrees. So for my angle 2, not only do I know angle 2 is 5y minus 20, it's also going to be equal to 90 degrees because it's that perpendicular. And then as well as for angle 3. Angle 3 is 2z plus 42, and it will also equal 90 degrees. So now we just need to solve for all three. So 90 divided by 4, we get x equals 22.5. When we want to solve for y, we're going to add 20 to both sides. So 5y equals 110. I divide 5 by both sides. Y equals 22. Then my third one to find z, I'm going to subtract 42 to both sides. So 2z equals 48. divide both sides by 2. Z equals 24. So we found our x, we found our y, and our z. So for example 3, I'm going to determine the precise name for the quadrilateral LMNP. So L is at the origin 0, 0. M is at a positive 3, positive 4. N is at a positive 8, positive 4. And P is at 5, 0. So here's my quadrilateral. I know from L to P it's 1, 2, 3, 4, 5. This is also a distance of 1, 2, 3, 4, 5. And I don't know it yet because we haven't learned that aspect yet, but these two lengths will be equal to each other because they are going from 0 to 4 on my y-axis for both of them, and they also move over a distance of 3. So I know all 4 sides of that. So to actually get the precise, though, I'm going to show you a quick demonstration. If I go up, I'm going to change my color. If I go up here, this is a 4, and I go over 3. This is also 4 and 3. So what we do, we're going to be learning this next trimester. If I take that triangle where I'm going up 4 over 3, if I square both sides, so 4 squared plus 3 squared, it's going to equal this side, I don't know, squared. So 4 squared is 16, 3 squared is 9. 16 plus 9 is 25. So x squared equals 25, and if I square root, x is 5. So if I know all 4 sides are 5, I know this is a rhombus. So now let's take a look at Theorem 611. Theorem 611 states the diagonals of a rectangle are congruent. So in this figure, let's label this A, B, C, D. So if I draw in my diagonals, pretend that one is straight, that means that the length of AC is congruent to the length of BD. So using that theorem, let's look at example 4. It says DEF is a rectangle. So I have DEFG. We want to find the value of x and the length of each diagonal. If DF, so from D to F, it's 2x minus 1. And then from E to G, it's x plus 3. Well, it says here in a rectangle that our diagonals are congruent. So that means 2x minus 1 has to equal x plus 3. So if I do and subtract x to both sides, I'm left with x minus 1 equals 3. Add 1 to both sides, x equals 4. So I found my x, but it says and the length of each diagonal. So now I need to find the length of DF as well as the length of EG. Well, DF is 2x minus 1. So if I do 2 times 4 minus 1, I know DF is going to equal 7. So then that also means that EG will also equal 7 because they're congruent. If you wanted to double check it, you would just need to do 4 plus 3, which does get you 7. Theorem 612, if one diagonal of a parallelogram bisects 2 angles of the parallelogram, then the parallelogram is a rhombus. Theorem 613 states that if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Theorem 614, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Alright, so let's take a look at example 5. I want us to fix something real quick. I'm going to add in those markings. Alright, so for the first one, can we conclude that the parallelogram is a rhombus or a rectangle? In this first one, we cannot, no. And we can't do that because we have a diagonal, but we know nothing about the diagonal. So this is no. This one, we can say yes. It's a rhombus. And we know it's a rhombus because this diagonal is bisecting two angles. So if we looked here, if one diagonal of the parallelogram bisects two angles, then it's a rhombus. In this figure, we have A, B, C, D, and it's telling us that the diagonal AC is congruent to the diagonal BD, which means my diagonals are congruent. So yes, this is a rectangle.